Everyone, today I'm discussing about how input-output devices work on a OS and how the basically the CPU do the any operations come, any programs comes, how it actually does the input and output operations. So let us see actually. So you can see here, this is the hard disk and this is my RAM, and this is my CPU. So I will just explain. So let's take an example. Yeah, I will just explain RAM. RAM is your random access memory. So whenever CPU has to do any operation, right, arithmetic operation, anything, so it will only access the RAM, not the hard disk. So whichever program has to be executed or has to be addressed by CPU, that has to be copied to the user space of the RAM. So OS space of the RAM will get loaded actually once you power on the basically the server. Then it will load the OS code, operating system, then the OS code will get loaded in the RAM. So our RAM contains two spaces actually. One is OS space that will have OS code, and one is user space that will load all your program which is written by the user, basically your all programs which was stored in the hard disk, but whenever it has to be executed, it will be copied like temporary in the user space, and then CPU will take that and process it. So let's take an example of one of the program. Like suppose I have a calculator and I wanted to do, a user wanted to do actually sum of for example just write it down. So I wanted to do sum of 2 plus 3 equal to 5 using the calculator, or I wanted to sum basically. So how this will be taken care in this in among all input output devices. So when you enter 2, right, so it will be always through the keyboard. So what happened is when you enter 2, so 2 so machine like computer always understand like whatever you enter, right, so it will be written in machine code, so it will be binary. So 2 binary will be your 0 1 0. So it will be stored in this buffer, and then this buffer will be copied to the RAM. Then similarly you will the user will enter 3. So it will be 0 1 1, and it will be copied to your RAM. So once so we will have the actually program that will run the arithmetic or calculator, right. So we will have a program for calculator, so that will be stored here. Actually that program will be here, and then we will have whatever input we have given here. Then CPU will actually it will get intimation like it has to do those operation, like some operation. So CPU has 2 unit, control unit and ALU. So for all arithmetic unit arithmetic operations, basically it will use ALU. So what it does, it will create a register space, and then it will copy all your whatever our input value, right, 0 1 0 and 0 1 1, and it will add up and make it, it is equivalent to 5. So it will do all those calculated in registers, and then it will copy to RAM. So this is the way that actually how input has been given and how CPU has processed that. And once that is done, it will display into the monitor. So it will go to the monitor and the output will be displayed. So later, yeah. So this is the way it has completed full calculator programs. Actually, the CPU has addressed that. So let's take an example of one PDF I have here because the like the saved copy PDF, like original copy is always in hard disk, because we can't save in RAM because it's a random access memory, so we will lose the data. So I have to write something in PDF. Okay, it can be alpha means it will be in letters only. So what it does is so we will have a program like Word doc. So so we will already have in user space, we will have that program. So we will have Word doc program here, and then that PDF will, we have to copy here, because then only CPU will run that program, and the things will get saved. So once it is here, then I have to write something, right. So I will use keyboard again. So whatever letters, suppose I have to write 1 or 2 3 lines, so it will be stored in that buffer, and then buffer will be copied into that PDF, whatever is stored here. And then once CPU has done that like executed that program, right, to save the PDF, then once everything is completed, then this PDF will again be copied to the hard disk, because we can't leave it here, because permanent saving will, otherwise we will lose the data. So if you see here, hard disk, like my hard disk or any my storage devices, right, like those will be always input output. If you see, it has given input PDF copied here, and then output is like it is saved here. So that is, so if you see here, monitor is my output because it always display, you can't give any input here. But keyboard is like is an input device, if you see, because we are giving input here. So this is the way things work. So there is one more important parameter, actually turnaround time, right? So basically it is the time that one process, right, once it is started till end, so it captures. So suppose my one of the process took start at 11 a.m. and it finishes at suppose 1 a.m. 1 p.m. So this total time till start to end is my turnaround time. So how basically if you see here, so it is actually sum of waiting time. Waiting time means the program might have copied here, but maybe CPU will pick up, right, once other processes are finished. So that is the waiting time. And burst time is my execution, like you have seen, right? So it has picked the value and then it has done this arithmetic calculation. So this is my execution time. And IO time is like basically input, it is copied and then it's copied back, right? So total of all time is my turnaround time. So this sequence you are seeing, it's not always fixed. So it can be IO time can be before, burst time can be later, or waiting time can be later. So that's it. So this is the way our all input and output device interacted, and how the CPU role is come into picture. So thank you. And if you have any comment, like please put your comments down, and any other topic you want me to discuss, please put in comments. Thank you.